All right, welcome to another Marcialis math moment. We're going to be solving literal equations today, also known as, aka, solving equations with more than one variable. Our objective today, students will be able to solve an equation that has more than one variable. Um, or, another way to say that, students will be able to isolate one variable on one side of the equal sign in an equation that has more than one variable. Solving. All right, let's get to it. So, solving equations with more than one variable, aka solving literal equations. They call them literal equations. We'll get to that in a second. So, we use these equations a lot in science. Sometimes you'll recognize them as formulas. So, like F equals m times A, where F is force, m stands for mass, and A stands for acceleration of that mass. These are literal equations or formula because each part is literally an important part of the equation or the formula. And it's an equation that's primarily made of letters, right? There's no numbers here. No numbers here. Back before you guys were born, this symbol was called a pound sign. Now it's a hashtag. But it used to represent the word number. Okay. In geometry, you'll see this. Like area of a circle is pi times the radius squared. So each one of these represents a quantity that you put into the formula to figure out the area. Or if you know the area, if you know this, you can solve for the radius. And this guy here, my angry potato head, he's just covering something for me. In finance, you see this. So you have A, which is your amount, kind of like how much money you earn, equals P times parentheses 1 plus R over N, close parentheses, raised to the N times T power. I know that's a lot, but just says R is my interest rate, N is the number of times my interest is compounded, and T stands for time. So number of compoundings. And P is my initial amount of money I put in, called the principal. You don't need to know that now. These are just some examples that you'll see that we use literal equations or formula often in the world on the earth. Example one, start simple. I have G, this is the letter G right there, equals 6 times X. Let's solve for X because I already know what G equals. So in order to do that, I have multiplication happening here. In order to undo multiplication, I use the inverse operation, which is division. That's why I write this vinculum here. It means to divide. Whatever I do to the left, I do to the right, and vice versa. So 6 divided by 6 is 1. Now I have 1x. And remember, we don't need to write that 1. It's implied when x is by itself. And I have g divided by 6. This is my final answer. Another way to write this is 1/6 times g equals x. These are the same. Example number 2 looks a little more complicated. Negative 3x plus 2c equals negative 3. So, draw my little line. Whatever I do on the left, I do on the right. Remember, we maintain balance. Let's solve for c. So in order to do that, I need to get c by itself. So the first thing I'm going to do is eliminate anything that's attached using addition or subtraction. In this case, it's negative 3x, so I'm going to do the opposite. So if I'm subtracting 3x, I'm going to add 3x to both sides. Any number minus itself is 0, so I have 2c equals. Now, these two guys here, I have negative 3, and I have positive 3x, okay? This does not have a variable attached to it, so it's just a constant. This does have a variable. So these are two different types of terms. I cannot combine them. So they stay separated, right? So they're here separated on their own. Now I have 2 times c on the left. I divide both sides by 2, right? And I have 2 divided by 2 is 1. Oops, sorry, 1c. And that equals 3 over 2x minus 3 over 2. This is the final answer. Example number 3. X times m equals n times p, and I wrote the little multiplication dots because I didn't want to be confusing. It just looked like a bunch of letters. Let's say we solve for x. Well, let's see, got my balance here. Whatever I do on the left, I do on the right. The thing that's keeping x from being alone is it's being multiplied times m. So I divide both sides by the same amount. In this case, my amount is a variable. So m divided by m is 1. So I get x equals n, that's a really bad n, sorry, np divided by m, or n times p divided by m. And that's our final answer. So, recap. To solve, you are isolating the variable on one side of your equal sign. I'm going to write equals in quotes there. Remember, oh, sorry. Left and right sides must be balanced. Whatever you do to the left, you do to the right. And then lastly, we do something a little different here. Mr. Potato Head, Angry Potato, is covering something. Oops. I want you to solve this on your own, and you're going to input the answer as a question in this video. I hope this has been helpful. And those real quick, couple examples. If you have any questions, you know how to get in touch with me.